Hi everyone, and thank you for registering for this online workshop, Mastering KumoRFM, a hands-on beta session to learn, test, and share your feedback. I'm Kitty Ivanovska and I will be your host today. Before we begin, I'd like to say thank you for joining the KumoRFM beta community. We are very excited to have you on board and can't wait to see what you will build with KumoRFM. In this KumoRFM beta session, you will hear from Jure Leskovec, professor at Stanford and co-founder and chief scientist at Kumo, Sally Liu, data scientist at Kumo, and we are also joined by Blaz Stojanovic, ML engineer at Kumo, and Matthias Fey, founding engineer at Kumo. They will be supporting the live Q&A session. Together, they will cover the understanding, the intuition behind KumoRFM, hands-on practice with KumoRFM, and live Q&A and user feedback. Before we begin, please remember to use the Q&A section to ask any question throughout the session, because at the end we will dedicate time to answer your question and give you feedback live. And now I'd like to invite Jure to open this session. Jure, over to you.
Great. Hi, everyone. Thank you for coming and thank you for responding to my LinkedIn message. So the reason you are here is because you responded to my LinkedIn post and registered your name. We were really excited by the amount of reception and how many people responded, and we are now running these sessions where we would let you kind of beta test this, get your feedback, and you'll also learn about what KumoRFM is. So just to talk about what we have built is kind of remarkable. In a sense, it fills a big gap or the void that is left out there by the language models, right? Today we have the language models, they take the text, they take the prompt, they do this kind of in-context common sense reasoning, and they give us more text or more code. But if you think about, let's say, machine learning prediction or business enterprise data, that is stuck 30 years back, where we are kind of building these models manually, engineering features, and so on. So what we have built with Kumo is a foundation model for predictions, right? Where we basically point the foundation model to our business enterprise data, generally in a tabular form, spread across multiple tables. We prompt the model, and the model will, without any training, give us an accurate prediction, right? So basically, a frozen model can make a prediction for any task on any data set. So the difference between traditional machine learning and KumoRFM is that in the traditional machine learning, we gather the training data, we train the model, we optimize the model, and then the frozen model takes the prediction data and makes the prediction. KumoRFM is a pre-trained model where basically we just point it to the prediction data, we prompt it with the task description, and we get immediately the prediction. So what does this mean? This means that we can have one pre-trained frozen model that we can point to any kind of data set, any kind of tables linked with primary foreign key relations. So maybe in e-commerce, this would be users, orders, likes, and products they purchased. In finance, it could be customers, transactions, accounts, and branches. In healthcare, it could be patients and records and visits and doctors. And across all these different domains, we can basically use our foundation model, point it to this data, ask it a predictive question, which is like, is a given transaction fraudulent? Is a given patient at the risk of hospital readmission? Will a given user churn soon? What is the user going to buy next? And the model will, basically based on this question, give us an accurate prediction based on the underlying data. And it's also able to give us an explanation of what patterns in the data made it gave this prediction. The point is that there is a snowflake here, meaning the model is frozen, the model is pre-trained. You don't need to train it. Just point to the data, ask the question, and you get the answer. So just how does this relate to the LLMs, right? The relation foundation models like the KumoRFM are basically filling the hole left by the LLMs, right? RFMs are not predicting text from text, but they are predicting outcomes from, let's call it, business data. And just like, LLMs replaced tedious, time-consuming NLP, natural language processing work, RFMs replace time-consuming, difficult and expensive predictive modeling work. So in this way, RFMs fill a hole, and they are not replacing or competing with LLMs, but they're kind of nicely complementary. And in the future, businesses are going to use both. For textual kind of human-like tasks, LLMs will be used. For this kind of more predictive forecasting type tasks where you are basing them on enterprise data, RFMs are going to be used. So the way this operates is we point the RFM to the tables, we prompt it with the description of the predictive tasks we wanna execute, and in about a second we get back the accurate prediction. We see in multiple tests, and I'll show you more detailed benchmarks later, is that the accuracy of RFM is at the level of manually built and trained models done by humans. If we further fine-tune the model on a specific data set or a specific task, the performance goes even higher. To tell you more about the application and accuracy of these models, here we tested KumoRFM on data sets that it was never trained on data coming from Stanford RL bench, which are different real-world relational data sets coming from a number of different industries and having a number of different predictive tasks. So overall, there is 7 different databases with 30 different predictive tasks, like customer lifetime value, churn, predicting what people are going to buy, what events they are going to attend, is a clinical trial going to be successful, and so on and so forth. And what we see that, for example, in terms of, let's say, classification tasks, like binary classification tasks, like churn, whether a user is going to visit a given website, whether a driver in a Formula One race is not going to qualify, or whether they're going to end up in the top 3 at the next race, for example, or user churn and so on. We see that the average accuracy of a pre-trained Kumo model just prompted with a given data set and the task is at the level of a custom trained GNN on these data sets. And actually, if you do the average over the data scientist built models, it's even a bit higher. If you would say, let's compare this to light GBM or like decision tree type models, the difference is quite large, right? This is for classification. We can also do regression, and we see similar patterns there, where the pre-trained model is essentially as accurate as or more accurate as customly built, manually built models with kind of traditional technology. Fine-tuning further brings the error down. Here, it's the regression, so the error is the smaller is better. On the previous slide, it was accuracy, so higher was better. And not only this model can do all kinds of classification and regression tasks, it can also do recommendation tasks, where we can say, what is a set of, let's say, items a user is going to engage with. And again, here we see really good average performance across a number of different data sets and across a number of different recommendation tasks. And we see much better performance than, for example, GraphSage or NBFNet and so on. So, but where is the big difference? The big difference is the time to prediction, right? To manually build a model, it can take weeks. With KumoRFM, it takes a second. So time to first prediction goes down by several orders of magnitude, about 5 orders of magnitude as we measured, right? So you can very quickly get those predictions, integrate them into your product, into your application, and get value out of them. So this is a quick kind of overview of KumoRFM, and through the rest of this session, we are going to go deeper. But basically, this is a foundation model for business data. It can make zero-shot predictions on your relational, tabular, enterprise data. You can also further fine-tune it to further push up the accuracy if you like. But why does it matter? It matters because now making predictions is very easy. Integrating this kind of predictive AI into your workflows, into your applications gets very, very easy. And why do we want predictive AI? Is because we want to make better decisions, right? The best way to make a decision is to predict what will the outcome of a decision be, right? And that's really what is important here. Just to say, I also want to invite you all to join us for a hackathon that we are organizing these days. We have very good prizes, and we are announcing this later today, early tomorrow. And we are going to give people or groups of people 10 days to build very interesting, exciting projects and applications, submit them to us, and then on August 20th in San Francisco, we are actually going to have a little event and announce the winners and give out the prizes. So stay tuned to the email that you will receive from us later today or tomorrow to register for the hackathon as well. So with this, I'm done with my presentation. So I will let Sally take over the screen and go deeper on how RFM works and what are the key concepts.
Okay, thank you so much, Jure. Now let me share my screen. Desktop. Okay, can everyone see my screen now? Okay, so thank you so much for being here. So in this session, I will walk you through the key intuitions and the key concepts about KumoRFM so you can better use it. So when it comes to this prediction, so we simplify prediction into two steps. And the philosophy of the design is we ask ourselves, what are actually the essentials when it comes to prediction? And we identify there are two things here. The first is you need to have data. And the second is you need to know what you want to predict. And by data, what we mean here is that there's a set of table connected by keys to form a graph. So once you have a graph, there's no need for data pipelines. When it comes to prediction, what you need to do is to write a SQL-like predictive query to precisely describe what you want to predict. So for instance, what happens here is you write a very simple query. So if you are already familiar with SQL, you'll notice these things are easy to parse and understand. For instance, in the first case, we have a customer churn. And to predict, okay, what's the likelihood in the next 7 days, and this customer will place order, what's the likelihood of that? And then we also have a regression case. For instance, we can forecasting item sales for items 100, 101. What is the total sum of their size of their price in the next 90 days? And also we can power recommendation. Say you want to know for this user, what are some of the items that are likely to place in the next month? So previously, machine learning requires a lot of steps. You need to do feature engineering, you need to do data pipeline, and you need to do model training. However, with this setup, everything is minimized, and that's how you can get a prediction so fast. And while it might appear like a magic, and I will share like under the hood, there are two things happening to power a very accurate prediction. The first is, because this is a pre-trained foundation model, we have a pre-trained graph transformer. So this is an encoder that learns representation across multiple tables. So that's why there's no need for feature engineering. And then once you have a prompt, what happens next is we have in-context learning, meaning at inference time, it retrieves label and subgraph examples as context to inform prediction. That's why there's no need for model training. And I can give you a very brief example, like with loaded data set to see what it looks like. So you will be able to experience this in our beta testing later on. So can everyone see my screen, like where I show the playground? Okay, so you can see it. So imagine you have this preloaded data set. So we have preloaded here for demo purpose. Say you have this item table, you have this user table, and you have views, orders, and returns. And here, the views are connected to item table by this item ID. Similarly, the user table are connected to views by this user ID, and similar for the orders here. So what happens next when you want you to make a prediction? As I said, this is a predictive query language. And what you can do here is to type it. Say you can also change it. Maybe I want to do 90 days. I can change that and to make a prediction. So, so as you can see here, immediately you already have a prediction out here. So what happens behind the scene is that it will do a few things. The first, it will generate in-context sample. And based on the in-context sample, and it will make the prediction there. And it will also generate the feature importance, like what drives the prediction here. And as a machine learning engineer, we also want to know, hey, how well this model performs. So that's how we also have a kind of this evaluation function where we can collect examples and evaluate the examples and give out the predictions here and some of the major metrics you can see and to evaluate how good the model performs. Okay, let's go back and see like, okay, now you have your own data, and then how can we actually put it into action? So there are two steps here, as I mentioned. The first part is data. So the first part, say, let me give you an example. Say, hey, I want to predict user 123's total order account in the next 30 days. So there's 3 steps. The first, import your data as a pandas data frame. And you can start very simple. Say you only want to predict the user's action about orders. So here you only need to import these 2 tables here and then convert it to a local table. And so here you need to assign 3 things. The first is the primary key here. So the primary key here is important because it indicates how the tables will be linked. For instance, if you say, hey, okay, the user ID is the primary key here. So when other table want to link with user table, they will look at the user ID as a primary key to do the drawing here. And also it determines the entity you can predict for. For instance, when the users, they have a primary key, then the user is the entity you can make a prediction for. And the second thing you want to indicate is the time column. So it indicates when the event happens. So this is super important because essentially we are trying to predict into the future. And so it's critical that we mark when the event happens. And also it influences our sampling strategy. Say when generating in-context samples, you look at the timestamp and make sure that there's no information leakage here. And lastly, you want to indicate the column semantic type. Here we call it S type. So that will indicate the column encoding. For instance, you have an int here. So there are multiple ways you can encode it depending on its age, its price, or its category, or its ID. So properly indicate the S type will impact the performance of the model. So lastly, you need to link the tables to form a graph. So it's super straightforward. Say from this order table, and there is a foreign key named the user ID, which can be linked to this user table with the user ID here. So once you have that and you already set up your data. So according to our observation, this setup usually takes about 10 minutes, 30 minutes, depending on how large or how complex your data is. But the good thing is once you have this graph set up, you can do all kinds of predictions based on this graph. And the second part is, okay, once you have the data, and then how can you do the prediction? So here we leverage on this predictive query language. Going back to the same example, I want to predict user 123's total order account in the next 30 days. So how to do that? There's 2 simple steps. So first, start with the entity. So here, the entity here is the user ID 123. So we can write, okay, predict, let's leave it as blank here. So for this user ID 123, so describe what you want to predict here. So here we want to predict what's the total count of orders in the next 30 days. You can write it I think it looks very much like SQL. So that's pretty much it. So once you have that, you can generate predictions immediately. Okay, and also we prepare a repository where we host all of our tutorial notebooks where you can learn more. So let me show you a few gems here. So if you go to our repository, you can see there's a list of notebooks here. And we have this quick start notebook, which we recommend as your first step. And we also have our comprehensive, the ultimate handbook, where you can learn how to leverage KumoRFM to its full potential. And for predictive query language, we also have this tutorial to teach you how to use that. And also, if you want to do benchmarking, we also provide 2 sample notebook where you can learn how to apply benchmarking on your data set. Okay, with that, let me go to the next slide. So I hope that provides you with a good enough primer to get started with KumoRFM. And the next session is our most essential part, which is our beta testing and Q&A with the Kumo team. So I will show you what to do. So for this beta testing, we want to hear very honest feedback for you as a user. Like, so we would like you to go to our website that I have just shown you, and then execute the quick start notebook here. And then there's also option you can test it with your own data, and we have our engineering team here to support you. And once you done that, you can complete our beta testing feedback survey here. Say our engineers are here to help. If you have any questions, you can answer the questions in Zoom, and we will answer. Okay. I think we can start with beta testing. If you have any questions, you can ask now. Okay, do you see any questions so far? Let me see. Okay, we have some. Okay, but in the meanwhile, let me put the instruction on the screen to make sure like people know what to do. Let me see, where is it? Okay. Do you see my screen here?
Yes, we can see the screen, beta testing screen.
Okay, that's great. Okay.
And maybe it's the right time when we need to remind our attendees that they need to use the Q&A session, the Q&A section for every question that they have, because in that way we can see those questions. And I think that we're receiving a couple of questions from Tal, Robin. So can you, Sally, can you see the question, Matthias or Blaz? Blaz?
Yeah, we're already typing many of the responses in chat.
Okay, yeah, maybe in the same time we can also answer like alive. So what do you think?
Sure. Which question should we answer?
So we received around 9 questions, 6 are answered. Maybe we can start answering live, or maybe we can just share the details for the question that we've already answered. So Blaz?
Okay, I can answer Venka's question. about can this model work with large data? So the question is, can this model work with large data that cannot fit into RAM in batches? Yes, it can. So right now we only support local modes where all of the context generation is done on the client side, meaning that you can only work with data that fits into your memory. But this is not necessarily a limitation. If you're able to partition the data yourself and batch it, so that you can fit the representation into your local memory, you can send batches over to the model to predict for. But we don't offer this as a service with the free API.
Thank you, Blaz. Matthias, I've already noticed that you've answered a couple of questions, so please can you read the most common and can you please provide the answer for everyone to know the details?
Okay, sounds good. I was about to answer the question about whether we can run the model locally, or it's an API service, and whether EU hosting is planned. So since I'm in Europe, I'm pushing for EU hosting as well. So that should arrive pretty soon. And then KumoRFM is designed in such a way that most of the actual computation around gathering subgraphs, generating labels from historical snapshots, is done on the client side, and this is kind of open source. You can inspect how this happens under the hood. But then the actual model, you've basically sent the context over what we gathered from your data, and you get a prediction back.
Thank you, Matthias. Sally, I think now it's your turn to pick a
Okay.
question to provide
Okay.
an answer.
I will take two questions. The first is it possible to receive the recording of the meeting? Yes, you will receive the recording of the meeting, and also feel free to ask here, because we will make sure to address all of your questions, even if we cannot answer here, and we will address your question in our follow-up email. And I think that's an easy question, but let me take another one from Da Zhang. Should I convert the contextual information into a relational structure first? I think the answer is yes. The way you convert it is you put it into a column and then indicate, okay, the type is X, and then the model will automatically encode this textual information.
Thank you, Sally.
Mm-hmm.
Blaz, I believe now it's your turn. After you, Matthias and Sally.
Okay.
Okay, let me pick an interesting one. So David Adams asks, can Kumo automatically handle time series joins between data sources with different granularities? I have daily emails. I'm not sure I understand the second part of data source, but yes, of course, if you have tables with different time granularities, this is not a problem for our representation, because we translate a relational database into a temporal graph. Each node can have its own timestamp, and the granularity doesn't matter too much. Of course, the model takes this into account when making predictions. So in fact, it is encouraged to include as much temporal information as possible, because that way we avoid any leakage. So each table should have a timestamp if possible, or if it's not kind of a static entity. I hope that makes sense. And then I'll also answer Nat's question. How well does KumoRFM scale to multiple tables that have to be joined? Or is it better to do some cleaning first to reduce the number of connections? That's an excellent question about data representation, which speaks a lot to this type of modeling, right? Because you don't necessarily have a lot of influence over the model, but you have influence over how data is represented. We encourage experimentation here because it's very easy to iterate end to end. So you can do a few joins, do some cleanup. But the idea is that KumoRFM works with any relational data. So you don't necessarily have to do any cleaning beforehand. So long as you have clean primary foreign key connections, you can join and create the graph over. We support up to 15 tables, I think. But as with anything in data science, it's recommended to start with less data and then add more and more data to see what's actually worth including. I hope that answers your question.
Okay. One question is, does KumoRFM automatically handle missing values? Is there a need for imputation from the user side? KumoRFM automatically handles missing values under the hood. So we are developing Kumo for over 3 years now. So this was something we wanted to get right, and this is also integrated into KumoRFM. And there exist different imputation strategies we use, and we also pre-train against if you're having NA values in categories, then this can be either like a separate category, it can be most frequent category, and so on. And in the end, for every semantic type or every data type we support, we have a special imputation logic implemented. That being said, if you want to control this by yourself, you can also fill or impute on your own, and then you have much more fine-grained control of how NA values are handled.
Okay, I'll answer the next question. Can KumoRFM be used for unsupervised learning on unlabeled data by any means? The answer is no. So KumoRFM is based on labels to generate the predictions here. So you do need to get some labels to get started. But I think a good use case for Kumo is that, say, you want to have a prediction for a large amount set of data, but you only have limited human resources to help you label it. So I think a good start approach is like you can have humans to provide labels to a small part of your data, and then leverage KumoRFM to do the missing data imputation for the rest of your data. So you can have a decent prediction on the whole data set.
Thank you, Sally. Blaz, are we able to continue with answering the questions?
Sure. So there's a question about column names. They can be arbitrary, and our model does not use column names to do any type of model predictions. The only time we do use column names is for automatic graph inference. So it's still advised for you to use clean column names, or at least if column names are corresponding across tables, make sure they have the same name, etc. And this is particularly important for IDs. And then there's another question. Actually, it's a double header from Tal. If the model is frozen, how do you learn from other data sets? Well, the model is frozen when we give it to you at serving time, but we have trained it on many data sets. So that's how we learn, and we continue to improve the model by training it on both publicly available and synthetic data. About predictive explanation, you've shown mostly counts as a feature. Yes, so we're working on explanations being better. So right now in the playground, we've not updated explanations to the latest kind of available feature that we have in the model. There's two types of explanations we can provide. One is at the column level. So kind of which columns are important and how important they are in general for predictions. And then for a particular instance you're predicting for, we can give you kind of more granular node level explanations. So which particular neighbors in the graph and their features are most important. And we're going to add this support to the SDK very soon. So you'll be able to both parse this explanation data yourself, and we're going to have a natural language interface to summarize the explanation for you.
Okay, I can group a few questions because there exist a few questions about like what we send to the server, how the SDK works. One question is around, can you give an example of the data that's sent to the Kumo API? And so let me try to describe that. So in the end, Kumo, what we send over the wire in KumoRFM is just the context and the subgraph of the entity we want to make a prediction for. that is sent over the wire to make a prediction for this single entity. Everything else is done on the client side, and that means that you don't need to upload your entire data set to make a prediction with KumoRFM. You're just sending the context. And so what we send as part of the context are like subgraphs of historical snapshots of your data. And these subgraphs have a particular depth you can customize. And this subgraph holds like the connections between different tables and their raw data. And the same holds true for the subgraph you want to make a prediction for. And so in the end, what we send over is like the time columns, the primary keys, the foreign keys, and the actual columns that are being used as features. Nothing is stored on the server. The server is like completely stateless. But if you want to make sure that your private data stays private, you can obfuscate your data beforehand, and that won't have any implications on the model performance. So independent of whether you're sending categories as strings or like as hashed integers, that doesn't make a difference to the model. The only exclusion on that would be related to text columns, where the actual text would matter to make a prediction.
Okay, I will answer the next question. Once a model is deployed using KumoRFM, how do you recommend handling concept drift over time? Is there support for automated retraining, fine-tuning, or in-context updates based on fresh data? So that's an excellent question. And this is actually an advantage for KumoRFM because we use in-context learning, meaning that every time we make a prediction, we draw this fresh sample from your data. So to make sure that we use the most updated data. So there's no need for retraining here. So it's guaranteed that when we make an inference or prediction, it's already using the most fresh data available here.
Okay, let me answer a bunch more. Questions about self-hosting. Unfortunately, you're not going to be able to self-host KumoRFM yet, but we are working with partners kind of on the enterprise level to ensure integrations work for them. So that's a quick answer. Then there's some questions about the actual use of SDK. So when creating a local graph, if you want to add another table to an existing graph, you can just do it. You don't have to reinitialize it, but you do have to reinitialize the foundation model, right? So when you have to recreate the KumoRFM object so that it actually updates to the latest graph. And then another question about the example notebook. You can see that you've created a graph with about 270,000 nodes and 1 million edges. Does this mean that data is row-wise and call-wise connected graph? And how is it used in relation to the frozen model? Well, as mentioned in the presentation, the data is converted. So each row is converted into a node, and then each primary foreign key connection that exists is an edge. So in this example graph, there's about 270,000 rows and 1 million connections between primary and foreign keys in the data. And I'll also answer the previous question, which is, do you provide any built-in tools for A/B testing predictions? No, but the API is very easy to call. So if you want to use it live in production and do an A/B test, we would be very excited, of course, and we're happy to provide support when trying KumoRFM on your own data. And you can join our Slack channel, Kumo Builders, to ask any questions, and we'll try our best to support.
I can answer one question, which is probably directed towards me. That would be around how to build a mini KumoRFM and which 5G classes I will be basing my model on. Okay, this is an interesting question. In the end, KumoRFM is also designed with 5G as its engine, so it's absolutely possible to build KumoRFM with 5G. I think what you need to have is like a heterogeneous model that can incorporate time and different node types. And then the one thing we also use, and which I recommend checking out, is our PyTorch frame library, which is also under the PyG team GitHub handle, which can take care of like how to process different types of data and bring them all into a shared embedding space. So if you want to build your mini KumoRFM, you need like a heterogeneous graph transformer or heterogeneous GNN, plus some kind of table encoding, which you can build yourself with PyTorch frame. And then you need an additional layer that kind of connects in context examples to the entity you're making prediction for, so that you can learn how different labels and their subgraph relate to the entity you're making a prediction for. I don't know if that's too high level, but yeah, let me know. Happy to shed more on that.
Okay. Okay, let me answer the next question from Ashley Kim. Would KumoRFM be able to train on data from a specific time period and test on another time period? So if you try KumoRFM, and I think a big advantage of us is like the time is a first-class citizen here. What I mean here is like you can actually indicate anchor time, which you can say, hey, we want to draw the in-context samples from a previous period, and then based on this anchor time, you test on this another time period. So I think this is totally doable and super easy to do. And you can reference our Quick Start notebook and to see how you can use the anchor time to implement this.
Okay, I can answer a bunch more questions, and I'll start at the top this time because I think we're doing more recent questions. So there's a question about how to evaluate how good the learned representations are from the pre-trained encoder. I think this is a two-level question. One is maybe a question for Matthias and the ML team. So what did we do during training to ensure representations are good? Well, we did what everybody should do when training foundation models. You evaluate on data that you've not trained on. And this also applies for practical use of KumoRFM, which is the only way to know how good the learned representations are is to use it on a downstream task you care about and you can measure the performance on. Then there's two questions about schema structure relations of the database influencing predictions, or what the relationship is between different graph types like star or normalized graphs databases and performance. This is a question that's really hard to answer across all data sets. As in my previous answer, experimentation is very much encouraged. A lot of the times, how you write the predictive query or what you want to predict dictates what the graph looks like, because there are some restrictions on the predictive query language. But usually we find that in graphs where there are kind of valuable signals, representation doesn't matter too much, of course, within the representations that kind of make sense. So I'm sorry that I cannot answer these two questions very precisely. And then, Kerry, can I just continue going? I think Matthias is gonna sign off shortly.
I can also take a few more.
Okay, then you go ahead.
Let me go first. Did we answer the semantic type support question already?
Go for it. No, we haven't.
This is an easy one. Okay. In the end, KumoRFM supports a variety of different semantic types, categoricals, numericals, multi-categorical, and so on. There's in particular a request here around bringing your own embeddings, and this is like absolutely possible. And so there's like a sequence semantic type, which you can use either for inputting like sequential data, but you can also use it to input embeddings directly. So this can be used to bring your own LLM encodings. It can be used to bring your own image embeddings and so on. So please try it out. There's one more question. It disappeared. Around latest time. So let me read it. There are classes of use cases that should not use latest time, but some past time for entity change or an entity relation change. How is that modeled in your prediction? So this is a good question. So by default, we are always making a prediction for the current state of the database, but oftentimes this might not be what you want. And so the model.predict function actually has an argument which is called anchor time, and by default it is left blank. But you can also pass in like an absolute timestamp for when you want to make this prediction. So you could go back to midnight or you could go back a week, whatever you want. And there's another option where you can pass in a string to the anchor time. So it would be anchor time equals entity. And that would mean you're making a prediction for when that particular entity has arrived in your database. So for example, if you're having a transaction and you want to classify this transaction as fraud, then you can use this anchor time equals entity argument to denote that you want to make this prediction for when this transaction was created. Another example where this might be useful would be for offline evaluation, where you have like a training set and a test set that you want to evaluate against with like particular timestamps, and then this comes very handy, and that are all use cases where you would potentially want to modify this anchor time argument.
Okay, I'll answer next question. What sort of limitations can we expect on KumoRFM API? Is it ready for production loads like few hundred thousands recommendations a day on the homepage of e-commerce website? So currently KumoRFM is free, meaning that we have a kind of like a daily limit of I think 1,000 query a day. So I would say for free tier, it's definitely not able to support for production load. But we will very quickly push a paid tier and where you have higher capability. So I would recommend in this case, you can first start with the free and see what's the performance in terms of like accuracy looks like. And once you feel it's ready for production, and you can reach out to the team and we'll work together with you to ensure it's production ready.
Blaz, are you able to answer maybe another question?
Yes, let me see. Question about probabilistic forecasting. So in our enterprise Kumo product, we already have forecasting available. We're gonna make forecasting available in KumoRFM very soon. But we don't yet support kind of probabilistic forecasting in the most proper sense. But if this is a popular enough feature request, then definitely we can consider adding it into KumoRFM. Let's see if there's only long questions. That's why it's taking me a long time to answer. 1 second. Do you want to go, Matthias?
Yeah, there's one question on the training objective for the pre-trained graph transformer. And so the basic idea is similar to what LLMs do. Kind of you have text and you kind of predict the next token. What we do in KumoRFM is like similar, but kind of mapped to the relational database setting. So we collected a massive amount of relational databases and augmented them and synthesized them. And then we have a random predictive query generator, which kind of gives us meaningful predictive queries for a given database. And that is how we train this graph transformer here.
Okay, I can take the next question, which is a question about benchmarks. Do you have any rank position in some of the known data sets to be compared with other architectures? So if you take a look at our paper, and we already provide some comparison to including a data scientist. So you can see the benchmark result there. And also in our GitHub repository, we also provide ways that you can do the benchmark. I think we also have a few other benchmark going on and release the results.
Okay. There's a question about support for regular data analysis type question answering. I'm not sure I absolutely understand this, but you can, a lot of the times regular data analysis is used to try and predict the future by kind of looking into doing queries into the past and then thinking carefully about what they mean for the future. So any question that you can formulate as a predictive query in our PQL language, you can answer with KumoRFM. So maybe that's not the best answer. But if if the PQL syntax aligns with the type of regular data analysis queries you might be doing, then absolutely yes. Otherwise, unfortunately.
Yeah, and also I want to do a quick clarification here. So when we talk about data analysis, usually it's based on past information, and we do some statistics and we do aggregation. So I think a lot of data analysis focusing on what's happens in the past. And what's KumoRFM's strength is to predict the future. So I think there's a distinction here, just to want to make it clear. And when it comes to data EDA, a really good use case for KumoRFM, it can impute missing data from there. So you can write a p-query when there's a missing data, you can very quickly impute those missing data.
Okay, so there's one question I'm not entirely sure I understand 100%, which is around and does there exist different visibility constraints between training and evaluation, such as some samples having access to more features or more recent features during training? And training, I would assume you're meaning context or in-context learning. And can this be modeled differently in the model? So in the end, the schema needs to match between what you have as part of your in-context examples and as part of your prediction entity. Otherwise, we wouldn't be able to infer like from these in-context examples how they relate to the entity. So the schema needs to be fixed to some extent, but you can obviously add these constraints through different links with time constraints. So you could imagine having like a fact table where you add additional information in during prediction time. But we kind of never tested this scenario in KumoRFM, so please use with caution. And if I'm misunderstanding this question, I'm sorry.
Okay, can I answer the next one? I actually find it super interesting. So David Adams has built a command line tool that generates sequential windows based on previous inputs. And then what comes next logic is currently rule-based. I think it's a super cool idea to use KumoRFM for this if you frame the problem as kind of best next action prediction. And if you have the data available, you can just join our Slack and we'll help you formulate the queries in order to answer this. One possible pitfall I see is that you may be very latency restricted and KumoRFM may not be kind of low latency enough for this, but with kind of intelligent caching, I think it's possible to work around that.
Yeah, I was also looking at this question and I want to answer that. I think that, our Slack is a great way to get support. So in case you want to build any kind of applications, you have ideas, you have your data, you can definitely reach out to us over Slack, and then we are happy to answer and trying to see, okay, how can we actually use KumoRFM in your application?
Okay, I can also answer the MCP question. So could you give insight into how the upcoming MCP server would integrate with an AI agent and what the use cases would be? So integration would be very simple as with any MCP. You just register it with your MCP client, wherever your agents live. And then what the tools that it will have available are very simple, right? So it would be the tools to take tables, create a graph, and then run predictive queries on that graph, with kind of additional tools for the agent to check if everything is okay. As for the use cases, even we're still thinking about this, but I think possibilities are kind of endless. Pretty much think of any use case where agent has to make some type of predictive inference in order to make an intelligent decision. So for example, if you're building an agent that handles call center calls, you can think about using KumoRFM tool to assess the risk that a user might churn if we don't give them a refund, or what's the best item to send them in a gift card to make sure they're not angry, etc. So things like that, or like fraud detection agents, etc. So if you're interested in building with the MCP, I'll again say join the Slack and let's build something together.
I can answer.
Go for it. Sorry.
Okay. A question about multi-layer answer. So from e-commerce or marketplace data. So it seems like there are two predictions to be made. High level, what is the LTV next K days? And low level, the predicted products purchased, a dictionary with expected time. So I think what you are asking here, if I interpret correctly, is that you want to make different prediction on different level of granularity. So to achieve that is actually quite straightforward. So instead of thinking it as like a different hierarchy, you can formulate it into two different queries. And the first query, you make a prediction on LTV. On different query, you make the prediction on the product purchased. So in this way, you can very flexible in terms of what you want to predict, and then combine them in your downstream service.
Blaz, Matthias, Sally, do you want to answer one more question maybe before we close our event today?
I can do two, in fact. So Dimitrie asked a question about 1 second inference speed. I mean, potentially it could be used for market trading. Try at your own risk, and this is not financial advice. But if you make a lot of money, we can negotiate some type of profit sharing agreement. I'm happy to be part of that. And then there's a question about making KumoRFM available in other languages like JavaScript. So right now we support the Kumo SDK, which is in Python. We're gonna have the MCP This really does depend on what users KumoRFM is popular with. If we see a lot of requests for JavaScript, I'm sure we can consider wrapping it up as a JavaScript package, just because we have a very clean API that we work around. So this will not be too much of a lift, but I think we would have to see evidence first that people will find that useful.
Amazing. Thank you, Blaz. Thank you, Sally, and thank you, Matthias. We reached the end of our workshop, and thank you all for joining and for your amazing question and positive comments. For any question we don't have time to answer live, we will follow up via email, and I hope all of you gain valuable insights about KumoRFM. Tomorrow, as Sally mentioned, we will send you an email with the video recording and some helpful links. Additionally, as Jure mentioned at the beginning of this workshop, we are hosting a hackathon. So please expect to receive the email today or tomorrow morning and register for that event, because as you see, there are many good prizes and you will be able to build with KumoRFM and to show to the world your projects and what you have built. Thank you so much, and thank you for your time and attention, and have a great day. Bye.
Thank you so much. Bye.
Thanks a lot.